Lesson number 1, geometric series. There are two types of geometric series, and these are finite geometric series and infinite geometric series. In this video, we are going to discuss the first one, the finite geometric series. Finite geometric series has limited number of terms. Now, this can be written as S sub n equals a sub 1 plus a sub 1r plus a sub 1r squared plus a sub 1r cubed plus and so on and so forth up to plus a sub 1r to the n minus 1, where S sub n denotes the sum of the first n terms, a sub 1 is the first term, r is the common ratio, and n is the number of terms. From the equation, you will notice that a sub 1r is the second term, or a sub 2. A sub 1r squared is the third term, or a sub 3. A sub 1r cubed is the fourth term, or a sub 4, up to adding the last term, which is a sub 1r to the n minus 1, is the n term. Okay? Now, the goal here is to look for a simplified form instead of this one, which is the S sub n. So what I'm going to show you right now is how to derive the simplest formula for S sub n instead of this one. Okay? Now from this equation, let us label this as equation number 1. And from this equation, we're going to multiply this by the common ratio r. The resulting equation would be what? R S sub n plus a sub 1r plus a sub 1r squared plus a sub 1r cubed plus a sub 1r to the fourth, and so on up to plus a sub 1r to the n. And this equation is labeled as number 2. Next, what we're going to do here is we subtract equation 1 by equation 2 term by term. Now, when we do the subtraction, we can only do this to those terms that are similar. Now, let us highlight those similar terms that can be subtracted. Okay? So it means those encircled terms can be subtracted. Okay? Not necessarily term by term. We're going to subtract term and its similar term. Now, you will notice that if we subtract a sub 1r by a sub 1r from equation 2, the result becomes 0. Similarly, 0 din ito, and the other three pairs being encircled also. And what will remain from the two equations is this one, S sub n minus r S sub n, which is now equal to a sub 1 minus a sub 1r to the n. So that the resulting equation would be like this. S sub n minus r S sub n equals a sub 1 minus a sub 1r to the n. And you will notice that from this resulting equation, the left side has a common factor of S sub n, while the right side has a common factor of a sub 1. So pwede nating ilabas yung common factor sa left side at dun din sa right side. S sub n is the common factor, so we factor it out so that the left side becomes S sub n times the quantity 1 minus r, while on the right side, ilalabas naman natin yung a sub 1 so that it becomes a sub 1 times the quantity 1 minus r to the n. And we divide both sides of the equation by quantity 1 minus r, so that on the left side, we can cancel this 2, okay? The common factor of 1 minus r. And the resulting equation is now our simplified formula for S sub n, which is this one. S sub n equals a times the quantity 1 minus r to the n minus all over 1 minus r. And this is the formula we want. So from this equation, we know that S sub n is the sum of the first n terms. A without subscript of 1 is actually the same as a sub 1, which is still our first term. R is the common ratio, which is not equal to 1. And n is the number of terms. Now, suppose if R is 1, what happened to the equation? So if R equals 1, we have a different formula, which is not this one anymore. And that formula for S sub n is simply S sub n equals A times n. Okay? Next. At this point, we can now use the formula to answer some examples like this one, number 1. Find the sum of the first 5 terms of the geometric sequence 2, 6, 18, and so on. So what are the given values here? What are the things that we need to get the sum? Okay, so it means when we say find the first 5 terms, we are actually going to find S sub 5, the value of S sub 5. So we need the first term, and that is 2. And also the common ratio denoted by small letter r, which is taking any 2 terms from this sequence, one term to be divided by its precedent, say 6 divided by 2, or we can consider 18 divided by 6. The result is still the same for the common ratio, and that is equal to 3. And the n is equal to 5. Okay. Taken from S sub 5 or from the problem itself. Yeah. Okay. Then we use the formula S sub n equals a quantity 1 minus r to the n all over 1 minus r. Substituting the given values. So S sub 5 equals 2 quantity 1 minus 3 to the 5th all over 1 minus 3. Simplifying this resulting expression using the PEMDAS rule, we have 2 times the quantity 1 minus 3 to the 5th, which is now 243 all over 1 minus 3. We know that 1 minus 3 will result to negative 2. And from this point, we can cancel 2 from the numerator and denominator, so that it becomes, both will now become 1. So in the denominator, from negative 2, it is now reduced to negative 1. And we can divide each of these 2 terms by negative 1. 1 divided by negative 1 will give us negative 1. And then negative 243 divided by negative 1 will become positive 243. And from here, negative 1 plus 243 will result to positive 242, which is the answer. Number 2, what about finding the sum of the first four terms? If the sequence is this one, 16, 8, 4, and you will notice that we have a decreasing terms for this sequence. So we can also say that this sequence is converging, meaning that the terms are getting smaller as it approaches to 0. Okay? Then that is S sub 4. Okay? Of course, we need the first term, A, which is 16, the common ratio R, which is 4 over 8, or 8 over 16, which is reduced to 1 half, and N is equal to 4. Using the same formula for S sub N, the finite geometric series formula, then substitute the given values. Okay? Then again, using the PEMDAS rule, or the order of operation, to simplify this resulting expression. Now, we make the two terms similar fractions, so one can be expressed as 16 over 16. But first, we have to evaluate 1 half quantity to the fourth, and that is actually 1 over 16. And from here, we can transform 1 by 16 over 16. So basically, we look for the LCD, making the two terms fractions of the same denominator. Likewise, on the denominator 1 being subtracted by 1 half, so we make the two terms similar fractions, so that's the reason why 1 becomes 2 over 2. Okay? Then we perform the indicated operation, which is the subtraction. 16 over 16 minus 1 over 16 is 15 over 16. 2 over 2 minus 1 half is 1 half. And you will notice that we can cancel 16 here. And the resulting expression is 15 over 1 half, or that is simply 15 times 2. And the answer is 30. That is the value of S sub 4, which is the sum of the first four terms. Next. How about number 3? Find the sum of the first 6 terms of the geometric sequence. 3, negative 6, positive 12, and so on. So you will notice here that the terms of this sequence are oscillating, so to speak. So meaning uh, the signs are alternating, positive, negative, positive, and so on. So we expect that the common ratio of this sequence is negative. Okay. So, okay, we look for S sub 6. So A sub 1, or A, is 3. R, the common ratio, which is negative 6 over 3, or that is negative 2. And the N is equal to 6. Again, using the S sub N formula, for the finite geometric series, we have this resulting expression, which is your S sub 6. 3, quantity 1 minus quantity negative 2 raised to the 6 all over 1 minus negative 2. Simplifying the resulting expression for S sub 6, that is 3, quantity 1 minus 64, which is the equivalent of this one, all over 1 minus plus 2. Okay. Meaning, we apply the rule of subtracting sign numbers, which is changing the sign of the subtrahend, and we follow the rule of addition. So that's the reason why from minus, the operator becomes plus. And from here, 1 plus 2, as we all know, is 3. And we can cancel 3 here. So that the remaining expression is 1 minus 64. And that is equal to negative 63. Okay. Next, how about number 4? Find the sum of the geometric series from the sequence 5, 10, 20, and so on up to 160. Now, we have a slight problem here. Okay. Indirectly, this example did not mention about the number of terms. So we cannot get the sum right away from this example. So we need to find first the number of terms. So how? So that is at this point as sub n. We have no specific value of n. We're going to look for that value. Okay? So a for the first term is 5. The common ratio is 20 divided by 10 or 10 divided by 5. That is equal to 2. Now, instead of the number of terms, ang ibinigay dito is the nth term or the last term. And that is actually a sub n, which is 160. Therefore, since we need to look first for the value of n, we need to recall using the n-term formula. A sub n, okay, which is this one, a sub n equals a sub 1 r to the n minus 1. Substituting the given values, 160, that is a sub n, equals 5 times r, which is 2 raised to n minus 1. And you will notice both sides can be divided by 5. And 160 over 5 is actually 32. And we can cancel 5 here. So what will remain on the right side is simply 2 to the n minus 1. And you will notice that 32 is a power of base 2. So we can replace this by 2 to the 5th. And you will notice that from these equations, we have 2 powers of the same base of 2. If that's the case, if we have powers having the same base, we can therefore say that their exponents are equivalent. So that is, so it follows that 5 would be equal to n minus 1. And solving for n here, that is equal to 6. Therefore, we are actually looking for the sum of the first 6 terms, or simply S sub 6. And since we already know the value of n, we can now proceed to compute for the sum of the first 6 terms using the S sub n formula again. Then substitute. A, R, and then n. Using the PEMDAS rule, so 2 to the 6 is 64. Then 1 minus 2 is negative 1. Then 1 minus negative 64 is negative 63. Then we can also divide negative 63 by negative 1. The result would be positive 63. So the expression will now become 5 times 63, and that is actually 314, which is the answer. So this is the sum of the first 6 terms of this geometric sequence.